Hello, my name is Jamsheed Agahi. Most of my engineering career, I've been a design verification engineer, working on such projects as hardware accelerators, supercomputers, networking chips, and so on. As verification engineers, no matter what project we work on, there is some sort of a hardware-software interface, or HSI, that we need to verify and interact with. Also, as verification engineers, we may not always be aware of the importance of a robust hardware-software interface in shipping a working product in a timely manner. I'd like to share with you some of my experience as a design verification engineer to shed light on two key ideas that can positively impact a product's time to market. One, how we as verification engineers can help reduce impact on software development schedule by being the bridge between hardware and software. And two, how we can reduce impact on the verification schedule, especially when it comes to the hardware-software interface. Multiple disciplines need to interact with the HSI. Both the verification and software teams see a collection of registers. They both need to configure a given block by writing some registers, and they need to read some registers in order to get information about the state of the device. There are interrupts that need to be handled and error conditions that need to be tended to. Both of these disciplines follow essentially the same steps in order to interact with the HSI. Remember, one of the key ideas that I mentioned earlier is being the bridge between hardware and software. Let's start by looking at the responsibilities of the verification engineer. The verification team has traditionally been responsible for developing a test bench, writing the necessary sequences and tests, and verifying the HSI and other functionality at various levels like block level, chip level, system level, and perhaps other intermediate levels. In the process of verification, no matter what level of verification we're performing, we usually have to interact with the HSI. And in this verification process, we're mostly communicating with the RTL design team about clarification of the functionality or certain bugs and so on. But there is usually not much communication between the verification and software teams. However, two of the disciplines that interact with the HSI are the verification and software teams. It seems intuitive that if these two disciplines interact with the same HSI, that we would see more communication between their teams. However, what we usually witness is that they're siloed. These two teams are siloed, and the verification engineer is usually not aware of the software engineer's issues with the HSI, even though they're using the same HSI to accomplish their tasks, one to verify functionality and the other to write software for a given block. How many of you communicate with your software engineering team? And here I come to the first key point that I'd like to get across. Verification as the bridge between hardware and software. Software development is costly. If we can minimize adverse schedule impact on software development, we'll minimize impact on the tape-out and consequently on the product's time to market. How can we accomplish that? One way we as verification engineers can help the software schedule is by having a better understanding of how the software engineer interacts with the HSI. That is, be in communication with the software engineer responsible for the block. This can in turn help me as the verification engineer uncover HSI issues early. Quite frequently, if a feature is difficult to verify, the software engineer will have difficulty writing software for it as well. Take as an example, the grouping of different types of bits in one register, which increases the potential for errors. Understanding the level of difficulty and the cost of software errors is key to being able to help the software schedule. We as verification engineers can initiate a discussion between the RTL design, software, and verification teams. This will result in simplifying the HSI, which removes both verification and software complexity and therefore reduces the chance for errors. This will minimize adverse impact on verification and software schedules. Again, here I want to emphasize the importance of being the bridge between software and hardware. I just talked about how HSI issues can also impact the verification schedule and how to mitigate this adverse impact. But there are other steps the verification team can take in order to minimize cost and schedule impact on verification. Verification is expensive. Therefore, verification should and can avoid extra cost and adverse impact on tape-out schedule by adopting a standard verification methodology such as UVM. UVM has a register abstraction layer that includes rudimentary built-in sequences for testing the HSI. And adopting a third-party tool which can generate the UVM RAL model and the HSI documentation. How many of you use a third-party tool for register automation? Also, avoid writing tools to generate the RAL model. Instead, focus on verifying the HSI. Verification is an expensive resource. You don't want to split your verification resources between writing tools and verifying the design. Other ways that verification can minimize impact on the schedule is to minimize changes to the verification environment from one version of the product to the next. This requires that the team participate in the architectural discussions. How many of you get to participate in architectural discussions of a product? Also, understand the bigger picture. What decisions affect the HSI? Even though you, as the verification engineer, will be working on a block, you need to have the big picture in mind. And understand how the product is going to evolve. Understanding the product evolution cycle enables you to plan for designing a single verification environment that works for different versions of the product with minimal change. You can think about reuse and modularization and layers of abstraction. If the RTL designer decides to move register addresses around in a subsequent version of the product, both the verification and software engineers will be impacted because their code will have to change. You should request that the designer avoid moving register addresses around. Again, here I'm returning to that first key idea, being the bridge between software and hardware. As verification engineers, we should consider discussing the HSI verification plan with the software team. When we discuss the verification plan for the HSI with the software team, we ensure that we use the same steps for verifying and interacting with the HSI as the software uses to program the block. For example, which bits in the register are set, or the order the registers are programmed in. Design complexity will also invariably have an adverse impact on the schedule. Consider when you mix read and write configuration bits with interrupt bits in the same register. This requires taking precautions in order not to inadvertently act an interrupt or change a configuration bit value. It is better to separate these two fields into two different registers and therefore reduce complexity. Also, avoid using a register or field access type that is not supported by a standard such as UVM. Otherwise, you'll have to augment your test bench, which requires time and effort. And request that hooks be put in for lab bring-up and debug. You, as the verification engineer, are aware of the complexity of the design. You should ensure that you have the tools to probe the internal state of a block in the lab. When working on a different version of a product, ask the designer to keep the existing register addresses and field positions in the registers unchanged if possible. That will avoid having to change your verification environment for a different version of the product, and it avoids impacting the schedule. In summary, be proactive and don't be shy about asking for changes to simplify the HSI. In conclusion, to have a robust HSI, there needs to be a three-way communication between the RTL design, verification, and software engineer responsible for the block. And take an active role in removing complexity from the HSI. Let the RTL designer know that simplifications need to be made to the implementation in order to avoid adverse schedule impact. Use a third-party tool to generate the desired verification and documentation files. Thank you.